The decentralized world of dApps offers exciting possibilities, but it also presents unique security challenges. Just like traditional applications, dApps are susceptible to vulnerabilities that can be exploited by malicious actors, leading to the loss of funds and user trust. Here are some common dApp security flaws that developers must address to build robust and secure applications. Insecure RPC endpoints. This vulnerability occurs when a dApp's RPC endpoint used to communicate with the blockchain is not properly secured. Attackers can exploit this lack of security to execute transactions on the dApp's behalf, potentially draining funds. Poorly designed or malicious dApps. This refers to dApps that have vulnerabilities in their code, either due to unintentional errors or intentional malicious design. These vulnerabilities can be exploited by hackers to steal funds. Thorough audits by security firms are important to prevent this. Phishing dApps. These are fake dApps designed to mimic legitimate ones, tricking users into connecting their wallets and surrendering their funds. Always double-check the URL and look for security indicators to avoid falling victim. Smart contract vulnerabilities. This category encompasses various vulnerabilities within the smart contracts powering dApps. Examples include reentrancy attacks, where attackers exploit loopholes to repeatedly call functions and drain funds, and unchecked external calls. It is where contracts do not verify the success of external calls, leaving them open to manipulation. Low liquidity. This refers to a dApp having insufficient buyers or sellers, leading to significant price slippage. This can result in users losing funds when buying or selling tokens. Always check liquidity before investing. Lack of data security. This highlights the importance of protecting sensitive user data, such as financial information, handled by dApps. Encryption, secure storage, and data privacy practices are important to prevent breaches. Signature verification. This flaw involves incorrect implementation of signature verification in smart contracts, allowing unauthorized users to execute transactions without proper authentication. Entering keys. This vulnerability arises from incorrect handling of key value storage in dApps, where developers might write to one key and read from another, potentially leading to data manipulation or unauthorized access. Controlled transactions. This flaw involves the lack of proper synchronization and confirmation mechanisms for interdependent transactions in dApps, potentially allowing attackers to exploit timing vulnerabilities. Lastly, smart contract vulnerabilities. This category, similar to the number 4, emphasizes the critical need for thorough code audits and secure coding practices to prevent vulnerabilities in smart contracts. Examples include reentrancy attacks, unchecked external calls, and improper handling of user input. By understanding and addressing these common dApp security flaws, developers can build more robust, secure, and trustworthy applications. Remember, a proactive approach to security is essential for the success and longevity of the dApp ecosystem.